Developers, our JavaScript Foundations now continues with arrays. Inside of the 06 arrays folder, just going to open up the first file there. And I'm going to prepare the little environment windows that we got going on. Open up that file in live server and dock this little window over to the left. So arrays is going to be our first object that we refer to, that we talk about, that is actually referred to as one of the many objects that are called data structures. A data structure is nothing more than an object that we use to keep track of, to store a collection or a list of objects. Okay, so that's as English as I can put it. It's an object that stores a list of other objects. There are a family of data structures, and the data structures that you would use are going to be dependent on the needs that you have of the data structure. Do you need to be able to store something fast, or do you need to be able to retrieve something fast? Those are the two primary decisions that you have in consideration. How fast do I care about how fast I can put it in, or do I care about how fast I can access it and find it when I need to find it? There are also other considerations though, like memory. Some data structures are going to take up more memory than others. So this is the very first topic about data structures that you might be listening to. So we're going to keep it simple, and we're going to simply talk about the mechanics of creating an array and how to access the individual members or elements of the array. Said another way, we're going to, how to create an array and how to access the individual items that are part of that array, right? So again, because an array we're going to use to keep track of a list of other objects, how do I reference and how do I access those individual members of that list? And so a use case for an array. Imagine, if you will, over here on my left-hand side, I have 4 friends. 5 or 6, 10, 20, 30. At a certain point, it's just too much. It's too much to create different variables for different friends. And not only does it become too much, it's just not a good solution. So a different solution would be to actually take my list of friends, and since that's a list, actually start treating them like a list. And again, an array is going to be such a list. Again, that's in English. An array is a data structure. It is a collection of objects. So here I am, I'm going to declare an array. And I always love to name my arrays in plural form, because it represents, a group of things, not just one thing, right? So here's friend 4, or friend, right? It's just one friend. Oh, that I misspelled. Let me make sure I spell this correctly later on, although I always if I misspell things, I will consistently misspell things going down the line. So here's my friends. I am going to put in, actually, let me just put in a couple of literal strings here so that we can see what this looks like. And I am also going to console log friends here so that we can see it in the console and see if we can gain any insights from the console as well. So I'm only starting with 2, just so that I don't crowd the environment over here on the right. So when the console pops up, we're going to go and see that we actually log. It actually says, look, array, and then in parentheses 2. Right now, why is it 2? Is because I have 2 specific elements. I have 2 members. I have 2 things inside of my array. If I look at the array as how it's drawn, though, it's really important to notice that the number 2 is not present. The 2 numbers that are present, 0 and 1, if we were going to count them, we might expect 1 and 2. But that's actually the first thing. Again, very similar to the string, which is a character array. The first element, the first item, the first member of the array is referred to being at index 0. Okay, so an array is a zero-based index, a data structure. It means that the first element is 0. Hopefully you don't come across a data structure that's indexed in a 1-based index, because that always throws you for a loop, because you get so used to working with index 0 being the first thing that when you come across the data structures that have a 1-based index, it's really terrible. All right, so if we use the little console and we click on that little caret, we see that, I'm trying to bring this bar up here, we see that 0 Alex and 1 Bill, just like we see it in the graph at the top. Now, what if I just wanted to see Bill again? I have to reference my array. My array is called friends. Not friend, but friends. And if I want to go at Bill, if I want to access Bill, I need to use Bill's index, which is 1. But I use it inside of square brackets. So these are square brackets. They're not parentheses. If you try parentheses, you would see that you get some type of error. So to access the array elements, or the members of the array, we use square brackets. And square bracket 1 means I'm going to go after the second element. So there's Bill. Now, if I wanted to, on the right-hand side, you see that I'm console logging the entire array. Or if I wanted to console log, again, Bill, I would have to console log the member at index 1. So this is how you access the array members. And this is us reading. So if I hit up arrow, this is us reading the member. But I can also write to that member. So I say, hey, you know what? I don't want Bill there. I want Robert. Robert is going to be that particular member. I hit enter. I get a little feedback that that's the setting that I set. And if I go back and try to output the friend at index 1, which is the second member, it started out as Bill, that we can see here on the left. But now I changed it to Robert. Because these members are strings, you can treat them like strings, right? So I'm going to say 0. Ooh. What happened to me? What happened to me? So I want to say, I wanted to copy that, and I want to concatenate my two friends. So now it says Alex and Robert, just like it's like any other string. I can do string concatenation, and naturally, I don't like that. I want to put a space in between there. So I'm going to put a space in between there. And in this format, right, these are simply strings. Now notice what happened here. I have Alex. I started out with Alex. Let me hit refresh. I started out with Alex and I started out with Bill. They are separate string literals than the string literals that I define my variables with. But let's now do this. Let's bring down friend 1 and friend 2. And I'm doing this because I want to show you that in spite of this looking like I have friend 1 inside of my array called friends, right? Inside, even though I have this variable declared and it looks like I want to place inside of the array, I want to put inside of this array this particular value. It might look like to you, looking at the left-hand side, that I'm actually putting this specific value, Alex, in it. That's not actually what happens. With strings, and I'm going to illustrate that by, I'm going to change now Alex to, I'm going to change Alex to Alexander. And we're going to see that the variable 1, right? Because the variable 1 is a pointer. What this actually did is that it pointed itself to a different string. Okay? So it no longer pointed to Alex. Meanwhile, friends 0, the first member of the array, it pointed to its separate copy of a string as well. Okay? So once you create this array, it actually creates a new copy of that string. Okay? Even if I were to say friend 1 is equal to friend 1 plus, all right, if I concatenated it so that it shows up as Alexander, you'll see that friend is still pointing to a separate string instance than the friend at 0 at the position of 0, the first element inside of friends. It's important to note again that strings are immutable, right? So in here, let me draw this. Let me get this here. Let me get this drawing going for us so that we can talk about this one more time. When I conducted this operation here, okay, when I did that, what I did was that I took my variable that was friend 1, right? So here's friend 1. It had a particular value, right? It was pointing to, let's just say it was pointing to Alex. It's pointing to, I'm not even going to point to that array because that might get you a little thrown, right? So here's Alex. It's sitting in memory. when I did the friend1 plus Alexander or Ander, what was it that happened? Is that I took this string, right, which was this one, and I told the computer to add to it some other string. This essentially made a new string, and it took the pointer of friend1 and pointed it down here at this new string. What was known as Alex is actually still hanging around in memory somewhere, okay? So this guy's still hanging around in memory, but then it's later on going to come back and get erased, okay? But the variable that we used to know as f1, friend1, is now pointed to this new string that lives in memory. Okay, so caution, a word of caution there in trying to understand how those arrays and arrays of strings behave. Again, I encourage you to go to the console and work with, play with, output the friends. Again, we can write to it. Friend 0 is going to be not Alex. I'm going to say it's Alice. And then if I output both my friends, I see now I have Alice and Bill. So this is an array now of strings. Let me comment this stuff out here now, and let's go see what the array of numbers might look like. And I wanted to make different numbers over here. Let's put those numbers in, and let's declare a variable var ages is equal to, and I'm declaring at the same time of declaring a new array, I'm actually providing the values. So I'm actually going to put age 1 and age 4 in there. Hit save and watch this guy. Oh, wait, I was getting an error because I got these guys. No good. All right, so the different age variables that I have, age 1, here's my numbers. Ooh, ages. Ages is undefined because I misspelled something, right? So if I open up my developer tools and I go to the console, it's going to say that ag4 is not defined, and that's because I did this. So notice how that little typo, it still recognized the variable because I declared it, but it was not able to do the assignment because I messed up. Oh, I messed up on the assignment. So I hit save over here, and we're going to watch this refresh. And we're going to see that ages now comes back with the two members at index 0, 25, and index 150. If I were to console log, again, so that you can see, right, we want to be able to see this guy in the console right from the start. It's 20 and 25. If I said ages, now if I wanted to get the length, if I wanted to get how many elements are in my array, how many things is this array pointing to, array.length is the number 2, right? There's 2 members there. If I take array 1, it's 50. If I take array 1, now watch, remember we used to do the plus plus? Hit plus plus, now let's see what happens and what's there. It's 51, right? So the plus plus operator, the incrementing operator still works. If I did ages, now this one, let's see what happens there, right? Because let's see what this looks like. Let's double check. Let's make sure we go through this. The current value inside of ages, the second element inside of ages is 52. If I do the plus plus in front of it like it was an integer, because it is an integer, what it's going to do is that it's going to increment the value and output it, right? There it is. And if I go back and check what's inside of, it is 53, right? And so that behavior is just like the same behavior when we dealt with integers. Let's look at the whole array again, see where we're at. We have 25 and 53. And just like I've been able to write to the element 0, I want to make that now, I'm just going to make it number 1. So now I have assigned the value of 1 to the element that is sitting at position 0, and there's the number 1, right? So that's confusing. And then, the JavaScript, awesome or not, there's going to be 2 camps here. Again, I have at element 1, 53. But what if I actually said element 1 is going to now be a string? Wow, that did an error because that's totally legit. So here in the JavaScript world, I can have an array. It started out as an array of integers, and it's still an array. But now it's just an array of, hey, I don't know, maybe it has an integer, maybe it has a string. Okay, so that's some of the cool things that you can do with an array. Again, here we look at the array with the different variables, and notice that the variable pointers are pointing to their own separate value. This changes dramatically when we start dealing with objects. So let's put one friend, let's put 2 friends back in here, and then I'm going to make another array, and this array is going to contain these 2 friends. Friend 1 and friend 2. And we're going to see how this is represented inside our graph. We have the friends array, right? And the friends array has 2 members, right? You can say that the friends array has 2 items in it. That's more English than technical speak. The array has 2 members. The array has 2 elements. The element at 0. Oh, let me use a different color here. The element at position 0, at index 0, points to an object in memory. Boom, here it is. It points to my friend Alex. The element at index 1 points to Bill. It so happens that Alex actually has a separate variable that's also pointing to it, right? So they're the exact same object. So the array index, right? What is located in memory, right? So in memory, this friends pointer points to an address in memory. Here it is. Here's the start my array. Then it has 2 slots. The first slot at index 0 is also a pointer, and it points to this little chunk of space in memory, that specific address in memory. The index 1 is actually another variable. It's another pointer, and it points to this area in memory. Okay? So all of these guys, all of these things, again, are pointers. They point to things in memory. Friend 1 points to this thing in memory, and index 0 points to this thing in memory. They point to the same thing. Let's use, we've talked about comparison operators. Let's see what the comparison operators tell us about that. So if I open up my console, and let me bring this down a little bit here. Let's access friend 1B. There's Alex. Wonderful. Now, friend 1B, is that equal to friend, what's the other guy called? Friend 2B. No, they're not equal. Let's go look at our friends array. And friends array 0 is Alex. Is friend array 0, right? So is the first member in that array, is that the same thing, comparison operator, the strict comparison operator with 3 equals? When dealing with an object, it is going to tell you if it points to the same object in memory. And there we can see that friend 1B is in fact the first, friend 1B is pointing to the same object that the first element inside of the array points to. So that's super cool. Now, if we come back here like I was doing before, what's going to happen? So look, again, array. I can make this into separate lines as well. Let me put the semicolon there because that looks better. Let me take friend, who am I going to work with here? I'm going to take Alex. I'm going to say friend 1B, that first name is now equal to Alexander. And when this graph renders, we're going to see, as we saw a moment ago, that yes, the element at position 0 continues to point to the same place that friend 1B points to, which is an object in memory that has a first name, and that now this first name is Alexander. That change is now shared. Really cool, really important. When you get into more complex software development, it might be the source of some bugs, because you might forget that you're working with an object that a bunch of pointers are pointing to. So if I wanted to visualize friend 1B dot first name, I see it's Alexander, and then that's going to be the same thing as if I try to access it through friends, the name of the array. The first guy is Alexander. I access the property. So look here, hitting the dot using dot notation. So now I'm using square brackets, the bracket notation on an array, to access the member of the array, right? I'll do it again. There's the entire object, okay? And now, here's the entire object. Now that I'm at the entire object, I can go back and you do dot notation to access the properties of the object at element 0, okay? This is now, because now this is an object, just like friend 1B, I can do cool things like I was doing before. I can start giving this guy a last name. And so let's just say that this is his last name. What is that going to do? If I were to access the entire object and visualize it, now we see that the friend 0 has the first name and last name. Cool. What happened to friend 1B? Friend 1B also now has the last name, right? Now, why did that happen? Again, let's go back to our little drawing. That happened because when I accessed this particular object through the element index, I was in fact accessing this object, okay? And when I accessed this object and I started tacking on different properties, I tacked on, well, let me do one because I did one. I tacked on the last name, which was I put the great. Once I did that, I did, in fact, I had a reference to this whole object, so I changed what that object was, right? I changed the properties, I added another property, and anybody who's pointing to this really special, this address in memory, I always like to point to that specific corner as this is where the object is going to start, this is the address in memory. Anybody who's pointing to that address in memory is going to now see the changes reflected to the objects that they access there. Let's do one more thing now. I'm going to take away Bill, because actually what I'm going to do is I'm going to give this guy his own friend Bill. Let's see how this renders. So now we see, back to my drawing, I have 3 variables, right? Friend 1, friend 2, and friends. I used to have these before. That's not the big difference. But what I actually have that's different is that this second member points to a new object that looks a lot like this guy. But the graph is illustrating to you that this guy is not this guy, right? This is not true. These two guys are not the same. You can see that the graph, the pointers, this pointer is pointing to this object and this pointer is pointing over here. They're not the same individual. They look like the same individual because they have the same values, but they're not the same object. We can again go back and use our comparison operators. We're going to go to friend, is friend 2. Friend 2b, is that equal to, so we got 3 equals. We're going to access the friends array, friends, and we're going to go and see if it's equal to the first guy. It's not, okay? And just for fun, it's not equal to the second guy either. Okay, and look, it might look like the same guy if you use the tools. There's Bill, and then we're going to go and look at another Bill, but those two objects are not the same. If you were to interact with this particular Bill here on the right, you're not interacting with this particular Bill here on the left. So now we have an array of 2 objects, and again, to illustrate that in JavaScript, there aren't that many rules. Well, there's a lot of rules, people. A lot of case sensitive. I mean, there's just a lot of rules, but we have a lot of flexibility. Let me take this string, that number. So I'm going to put in friend 4 just because I can. Let me put h1 because I can. And let me open up my developer tools. and we're going to see that we have an array of 0, 1, 2, 3, 4 members, index 0. We see that the first two are objects. We see that the third one is a string, and we see that the fourth one is a number. Again, programmatically, you can evaluate that programmatically because you can use a type of operator. So here's the type of operator, and I want to access, oh look, let's do friends, because we're going to talk about this later. Friends is, what's the type of, it's object. So that's not that helpful sometimes. So we're going to find out a way to do it, how to detect if this object is an array. We'll do that in another video. But when I see, what I want to look at is, what is the type of the first element? That's an object. What is the type of the third element? That's a string. And if I come back, and what's the type of the fourth element? That's a number. If I use something that's not there, we're going to say type of is undefined. So we can reference those objects. Those objects still maintain all of the properties, right? The behavior of how they're going to behave, that remains. Their strings, their objects, their numbers, just like they were when they were standalone variables. They behave the same. It's just now that we've collected them and grouped them in this data structure called an array. All right, so play with this a little bit. Create arrays of different types. Access them. Write to them. For example, actually, let me finish writing. Let me do one more writing exercise. Example, I'm going to take my friends, and I want to access. Oh, look, here comes all the arrays, right? So look how this is being visualized. That's interesting. But what I want to do is I want to go to one of the friends that is a object. The friends that's an object, who's 0. So that's Alexander. What if I was done with Alexander? I don't like Alexander no more. I'm just going to, let's say, see you later. And I'm going to null out that pointer. I've taken that pointer and I've pointed it to null. So now when I spit out my collection of friends, I see that, boom, I got no more Alexander. I've got null. That object that I was pointing to a moment ago, now there's nothing pointing to him. There's no way to get him back. And all the other things remain the same. If I do friends.length, I am going to be told how many elements, or how many members that array has. So work with this, play with this, read and write to the arrays, and see how they're visualized in the graph before you move on to the next video.